Okay, so your homework for tonight is to get ready for Unit 2, Systems of Linear Equations and Inequalities. We're going to cover quite a few things in this unit, but it's a pretty fun unit actually. Converting equations from standard form to slope-intercept form. We're going to work on that this week in class. Graphing linear inequalities, which you actually already know how to do. And then systems that involve all of those. And I'll explain more what those mean as we go along. So I need you to flip to page 2-1 in your packet. And this section is just talking about converting y equals mx plus b and ax plus by equals c. So y equals mx plus b we know is called slope-intercept form. And ax plus by equals c would be standard form. So you're going to hear me use those two terms quite a bit. So we're going to learn how to convert from slope-intercept form to standard form and back and forth again. Okay? So these are the most common types of linear equations you're going to see. When one is dependent on another, you're usually going to see it as slope-intercept form. And we know that that means that our function has a beginning point, which is our y-intercept, and then a rate at which it changes, which is our slope. And that we've been doing a lot of things in slope-intercept form. We have done graphing in standard form at this point, and that's when you have both of your terms on the left-hand side, and when you have both of your terms on the left-hand side and your constant on the right. You see this a lot in systems because you're usually talking about maybe you're buying two items at a store and that equals a certain amount of money. You're ordering two different things at a restaurant, that it gives you a certain, your specific total that you're paying. So you'll see standard form a lot in systems of equations. Okay, so so this is talking about graphing on a calculator. Of course, we're not going to do that in our class because you all are graphing pros now, so you don't need to really worry about that. There are graphing calculators. You can definitely graph on one of those, but we don't even need to do that. So flip to page 2-2, and we're going to do some examples. So we're going to see how these two functions are related to each other. So 4 students want to write 12x plus 3y equals 9 in equivalent slope-intercept form or y equals mx plus b form. Here are their explanations. So here we've got 4 going on. So let's look at what happened. So they all took the original equation, 12x plus 3y equals 9. Jared, it appears, moved the 12x to the other side, which made it negative, because when you move from one side to the other, it makes it negative. And then he divided all three things by 3. So first he moved the x term, and then he divided by 3. Okay, Molly, let's see what Molly did. Molly also moved the x term, but she put it in a different place. She put it back here, and then divided everything by 3. So she did the same thing, but these, her x term and her constant are flip-flopped. Okay? So let's see what Allie did. So Allie, it appears, to go from 12x to 4x, you divide by 3. From 3y to y, you divide by 3. And from 9 to 3, divided by 3. So it looks like she divided this entire function by 3 first, and then she moved the x term to the other side. So now she has slope-intercept form. She's got y equals negative 4x plus 3. Negative 4 is your slope. 3 is your y-intercept. Okay, can do that. And then she moved the x term. Then Mia also moved, let's see, how was hers? Oh, do you see a mistake here? I see a mistake back here. Let's come back to that in a second. Okay. Just caught it. I hope some of you were yelling at me. So Mia moved her 12x to the other side, which gave it a negative 12x. And then she divided everything by 3. But then she switched these two terms around. See if you see any problems with that. The problem I have with that is that that used to be a negative 4x, and she turned it into a positive 4x. And that was a positive 3, and now it's a negative 3. And the only time you can do that is when you move it to the other side of the equation, which she didn't do. So this one's going to have sign issues, right? So that one's going to be incorrect. Also, Molly had a problem here because she divided 3y by 3 and 9 by 3, but she forgot to divide negative 12x by 3. So let's see who got an equivalent equation. So Jared and Allie seem to be doing fine. They did the same two steps, they just flip-flopped when they did them. So they moved the x term and they divided by the coefficient that was in front of 3. So Jared and Allie were okay. Allie were okay. Molly forgot to divide all terms. And Mia switched her signs. Okay. So what are the steps to converting an equation into a slope-intercept form? And this is nice because it's exactly count them, 2 steps. And we can see that Jared and Allie did both of those steps, but in 2 different orders, which is totally fine. So the steps to converting a standard form equation from slope-intercept form to, from standard form to slope-intercept form. The first step is to move the x term to the right side, right-hand side. And then divide by the coefficient, the number in front of y. Okay? So that's all that we need to do. And we're going to do practice on this in a minute. What does it mean for 2 equations to be equivalent? It means that if you set them equal to each other, and solve, everything will cancel out. That's a mathematical way to prove that, right? The other thing it means is that any input will give the same output. For both. Okay? So, which means that the coordinate pairs are solutions for both. So any x and y coordinate that is a solution for one, if they're equivalent, it needs to work for the other one. Solutions for both. Okay? So get all of that written down, and then we'll go over to 2, 3 for some practice. Okay. So, now in my class, I know that we have been changing things into slope-intercept form a little bit, but our preferred way to graph standard form is to actually use our intercepts. But for now, we're going to actually go through and change our equations into slope-intercept form. So remember what the first step is. First step is to move the x term, and that's going to make it go opposite of what it originally is. And then divide by the coefficient, the number of y. So our first move here is we're going to move that x term to the other side. So the opposite of x is negative x. Now 4 and negative x can't be put together. So now we're just going to have negative y equals negative x, or negative 1x, that works too, plus 4. All you did was move this term to the other side. When it moves sides, it changes signs. And now I need y as my standalone coefficient over here. Right now I have negative y, which is the same as negative 1. So I have to divide everything by negative 1. So I would get y equals negative 1 divided by negative 1 is just 1. So x, 4 divided by negative 1 is negative 4. Okay? So now if I'm going to graph that, see if you can graph that before I do. Your intercept is going to be at -4. Your slope is going to be 1 over 1. So you go up 1 and over 1. Up 1 over 1. And there's our graph. Okay. All right, so let's try the same thing for B. So I'm going to move my x term. When it moves to the other side, it becomes -4x. I'm going to always write that in order so that my slope comes first. So -4x minus 24. I just reverse those two, but the signs stay with them. And now I have to divide by the number in front of the y. So, which is 8 in this case. -4 over 8 reduces to -1 x over 2. And -24 divided by 8 is -3. So that's my equation. When I graph that, I begin at -3. And I know because this slope is negative, it's going to go downhill instead of uphill. So I'm going to go up 1 and over 2, or I could go down 1 and over 2. Okay? So I'd like you to try changing these from slope-intercept form and then graphing them. You can just sketch yourself quick little graphs at the bottom. They don't have to be perfect. Please do not write all the little tick marks. You can just estimate it. Okay, so hit pause, change these to slope-intercept form, and then come back and check your work. Okay? All right, so now we're going to check. For A, I'm going to move my x to the other side. So that comes over here. And I have 3y equals 2x minus 25. Now I have to divide everything by 3. So my equation is y equals 2/3 x minus 25 over 3. And you're going to say, oh, Miss V, but I have a fraction and I don't know how to graph a fraction. Sure you do. Let's figure out about how much 25/3 is. So 3 goes into 25 times 8 with a little bit left over. So you have about 8 1/3. Okay, so -8 1/3 is going to be down here. And then we're going to go up 2 and over 3. So that's approximating where that graph is. Okay. Here I've got my x is where it needs to be. It's on the right-hand side of the equation, but my 10y is not. So I need to bring that over. So it needs to be on the left. The numbers need to be on the right. So let's move that all in one step. And we have -10y. So this is coming over to this side, and the 10y is coming over to this side. They both are going to change signs when they move. So I'm going to get 5x minus 600, and now I need to divide everything by -10. So that cancels out. I get y equals 5 divided by -10 is 1 over -2x. Negative divided by negative is a positive, and 600 divided by 10 is 60. So that number would be way up here somewhere, and that's going to be a downhill line because that slope is negative, and you're going to go down 1 over 2. So it's going to be a really shallow flat line like that. Okay, last one. So we're going to move our x term to the other side. Y is on the correct, it's on the left, which was where we want it. We're going to move that over. When we move that, it becomes a -x. So we get 5y equals -x plus 0. And then we're going to divide everything by 5. Remember, if there's no number in front of a variable, it's always a 1. And you get y equals -1/5 x. 0 divided by anything is just 0. So you can write plus 0, or just leave it just like that. That would be fine too. So your intercept is at 3. Your intercept is at 0. And then you're going to go down 1 and over 5, or you could go up 1 over 5 to the left. So that too is going to be a pretty flat line. Okay, check your work. Make sure you're good to go. And let's go on to 2-4. Okay, so now we're doing the opposite. And this is one of the reasons that I had you do fraction busters yesterday and the day before, was to make sure that you know how to get rid of those fractions. So remember that you're going to multiply all terms by the common denominator and then cancel out. We had a worksheet on this. We did this in class. There's also a Fraction Busters quick little reminder video on how to do this. That would be helpful. So I'm going to look at this, and this is not, I want my x first, so before I do anything, I'm actually going to rewrite the order of this. That's -2/3 x plus 1/4. So now all I have to do is find a number that 3 and 4 will go into, and the easiest way to do that is multiply everything by that number. So 3 times 4 is 12. And, sorry, the easiest way to find that is just multiply the two of them together. So I need to multiply all by 12. So multiply everything. All the terms, left side, right side, everything. So 1, 2, 3 terms need to be multiplied by 12. So we're going to multiply that by 12, that by 12, and that by 12. So left side's easy. We just have 12y. And, oh, and one of the rules in standard form equation, the reason we're doing this, no fractions in standard form. Ever, ever. That's a rule. Okay? So, 3 goes into 12 4 times. Now by doing that, I eliminated my fraction. Now I just have to multiply those two. So 4 times -2 is -8x. 4 goes into 12 3 times. 3 times 1 is 3. So now remember what standard form has to look like. Both my x term and my y term need to be on the left-hand side, and my constant needs to be on the right. So 3 is doing okay. It's my constant. It needs to stay over here. -8x needs to shoot over to the other side. And remember, when it moves, it's going to change signs. So we're going to add 8x to both sides. And then you want to put your x term first, so 8x. There's no sign in front of that 12y, so it's plus 12y equals 3. And that is the standard form of that equation. Okay, so remember, x terms first, y terms second. Adding those together equals the constant, the number standing alone, and no fractions. Okay, try to do b on your own, and we'll see how you do. So I'm going to multiply everything by 2, because the only number I need to get rid of in my fraction is 2. So I'm going to multiply every term by 2. So 2 times 2x is 4x. 2 times y would be 2y. And 2 goes into 2 once. 1 times 1 is 1. So everything so far is okay. But remember, I need my x term and my y term on the left-hand side. Right now, my y term is on the right-hand side. So I need to move that over. And the way I do that is by doing the opposite. So they're going to cancel out here. And I'm going to have 4x minus 2y equals 1. And I'm done. Easy. Okay, I want you to try the 3 at the bottom and then come back and check your work, please. Okay, so my x term is on the left, but my y term is on the right. Both need to be on the left-hand side. So I need to move that 2y to the other side. And remember, you can't add things that are not the same. These are x's, these are y's. You can't combine them. You can only just sit them next to each other. So you have x minus 2y, they canceled from here, equals -3. Now check, do I have what I want? X term is on the left, y term is on the left, constant is on the right, and I have no fractions. So I am done. Y term is where it needs to be, it's on the left-hand side. X term is on the right-hand side, I need it over here. I'm going to have to do the opposite, which is add 3x to both sides. So when I cancel that out, I will have 3x plus y equals 5. Check again. Do you have your x terms on the left-hand side? Yes. Do you have your y terms on the left-hand side? Yes. And your constant on the right. So we're good to go. Here you say, oh, Miss V, I don't have a constant. That's okay. Still the same rule applies. Everything needs to come over here. You really do have a constant. It's just that your constant is 0. So the 5y needs to move. And so now you'll have x minus 5y. They cancel from this side, equals 0. Okay, we'll do lots more practice in class. And so flip to 2.5. So 2.5 and 2.6 should be review. That is graphing inequalities. It was on your exam. And so what I'm going to have you do is, I'm going to do this one with you, and I'm going to allow you to do this 4 on 2.6 independently, and then come back and check your work. So you're graphing them just like slope-intercept form. The only difference is whether we have a dashed line or a solid line and where our shading is. So I'm going to begin at positive 5. My slope is -2 or -2/1. So I'm going to go down 2 over 1, down 2 over 1, all the way down. I'm going to have a dashed line because I remember that less than or greater than is dashed. Less than or equal to or greater than or equal to is solid. This is a greater than. So I'm going to graph my dashed line. Since it's greater than, I'm going to shade everything above that line. So go ahead and do 1 through 4 on page 2.6, and then come back in a moment to check your answers. And I'm going to check and see why Mr. Price is making goofy faces through my door. Hang on. Okay, so this you can change that into slope-intercept form, and since that's what we're practicing, let's go ahead and do that.
Yep.
So if I move my X term to the other side, Mr. Price, does it stay positive or does it go negative?
It's got to go negative. It's going to the other side.
Why?
Because it's the other side of the number line.
Of the number line? Of the inequality? Close. Close. He's an English teacher. You have to spare him. Okay, so we're going to move that to the other side. And what do we get now, Mr. Price?
3 times -3x is -9y.
Oh, don't listen to him. 3y is greater than
-3x.
plus.
12.
Oh, he's so good when you tell him exactly what to do. Okay, and now what am I going to do? I need y by itself. It's currently being multiplied by 3, so the opposite is.
Okay, so the alligator eats the bigger number, right?
Wait.
So
Yeah, but what's the opposite of multiplying by 3?
subtracting 3.
Wow.
Dividing by 3.
Epic fail, yes. Dividing by 3. So we get does that say greater than or less than, Mr. Price?
That says greater than.
It does. Very good, Mr. Price.
Why are there letters?
-3 why are there letters and numbers and tigers and bears? Oh my. What's -3 divided by 3?
-3 divided by 3 is -2.
No. What's 3 divided by 3, Mr. Price?
1.
Oh my goodness. What's 12 divided by 3, Mr. Price?
4.
Oh! Okay. So
Team.
now we're going to start at 4. And our slope is negative, so we're going to go downhill. So we go down 1 over 1. Is that going to be a solid line or a dashed line? Say
Dash.
dash. There you go. Good guess. And if it's greater than, is it going to be above that line or below that line?
It's going to be below that line.
Greater
Why
than?
didn't you use?
So when you go greater somewhere, you go into the ocean
Oh, it's gonna
instead
be
of into
over?
the sky? There we
It's gonna be
go.
over.
Yeah.
Why don't you use a ruler to make the line straight?
Oh, because we don't worry about that in math.
No.
Ro can worry about straight lines.
Okay.
I'm not overly concerned with it. That's too much. Okay, number 2, we're going to start. Where is that on the y-axis?
Can't see it on there.
Oh, thank you. They tell me that all the time, by the way.
Where's what?
-1 on the y-axis.
It's going to be right below the middle there.
Good point. Oh, very good.
Wait, there we go.
Oh, there we go. Okay. Now my slope is 4 over 5, so I'm going to go up
4,
4 and over
5.
5. Is that going to be a solid line or a dashed line?
It's going to be solid.
Ah,
It's going to be a dash line.
it's going to be dashed. I thought you said that. I thought that you. And does that say less than or greater than?
That says less than
Good. So what's a number less than -1?
-2.
Ooh, very good. So it's going to go below that line. Very nice, Mr. Price. Oh, he's cruising now. Okay, let's.
Look, I don't want to do all your job for you.
You're
I'm doing your
making.
job for you.
Yeah, right. So we don't have this in slope-intercept form. That 6 needs to move to the other side.
Duh.
So how do we move that? What's the opposite of 6?
Circle the 6, draw a line over the other side. -6.
Oh, very nice. So we have y is greater than or equal to 4x minus 6. Where is -6 on the y-intercept? On the
It's going to be
y-axis?
6 down
6 down, right there.
at the very bottom.
And my slope is 4 or 4 over 1. So from that point, I go up
You're going to go 4.
and over
1.
1. Is that going to be a solid line or a dashed line?
Solid line.
Solid line. And does it say greater than or equal to or less than or equal to, Mr. Price?
It says greater than or less than or equal to.
Greater than or less than or equal to?
Yeah.
It's a hybrid?
Yeah. Is that what that says?
No.
That's a shark, that's an alligator eating, that's greater than.
That's a greater than, very good. And so, give me a number that is greater than -6.
1,658,000.
Perfect, and that would be way up here somewhere. Yes?
That's pretty good.
Beautiful. Okay. Last one. All right, since this number always tells us where we start, what do we do when we have no number
How
there?
many are we gonna do though?
It's the last one.
God.
You sound
Okay.
like my freshman.
So now what?
So -2x is the same as -2x plus how many?
0.
0. Is this in slope-intercept form, Mr. Price?
Yep.
Oh, yes, it is. So where is our beginning point going to be?
0.
Where is
Right in the
zero?
middle, smack
Right
down the
square
middle.
in the middle.
Mhm.
And if we have a negative slope, are we going to go uphill or downhill?
We're gonna go downhill.
Oh, very good.
We're gonna use a pencil, you're supposed to use a pencil.
Nah, they can see it better in this pen. Okay, and so from this point, I'm going to go down.
1, 2.
I was showing him this, by the way,
No,
children.
she wasn't.
Down 2, and over 1.
1.
Ignore that little dot. It's Mr. Price's fault. He distracted me.
Ah.
Okay, and then,
Yeah,
or we
pencil
could
might be a
go
problem.
up to, this is probably true. Is that going to be a solid line or a dashed line?
That's gonna be a solid line.
Solid line. That almost hits the dots. And give me a number
A
that's...
ruler would have fixed that.
That would have, and a pencil. What's a number smaller or less than 0?
-652.
And it'd be way down here, so it's going to be on this side. Good?
That's good. Do they have to do all those?
That was their notes. They're actually doing notes.
Oh.
So, say hi to all your little freshies that
These
you'll
are
see in a
freshmen?
couple years, yes.
Hey guys,
Any words of advice, Mr. Price?
stop being freshmen.
It helps.
Okay,
Okay,
let's talk
Say
about
goodbye, Mr.
football.
Price.
Goodbye, Mr. Price.